A modular building is a prefabricated building that consists of repeated sections called modules. Modularity involves constructing sections away from the building site, then delivering them to the intended site. Installation of the prefabricated sections is completed on-site. Prefabricated sections are sometimes placed using a crane. The modules can be placed side by side, end to end, or stacked, allowing for a variety of configurations and styles. After placement, the modules are joined together using inter-module connections, also known as interconnections. The interconnections tie the individual modules together to form the overall building structure. Modular buildings may be used for long-term, temporary, or permanent facilities, such as construction camps, schools and classrooms, civilian and military housing, and industrial facilities. Modular buildings are used in remote and rural areas where conventional construction may not be reasonable or possible. For example, the Halley 6 accommodation pods used for a BAS Antarctic expedition. Other uses have included churches, healthcare facilities, sales and retail offices, fast food restaurants, and cruise ship construction. They can also be used in areas that have weather concerns, such as hurricanes. Modular buildings are often used to provide temporary facilities, including toilets and ablutions at events. The portability of the buildings makes them popular with hire companies and clients alike. The use of modular buildings enables events to be held at locations where existing facilities are unavailable or unable to support the number of event attendees. Construction process. Construction is off-site, using lean manufacturing techniques to prefabricate single or multi-story buildings in deliverable module sections. Often, modules are based around standard 20-foot containers, using the same dimensions, structures, building and stacking/placing techniques, but with smooth instead of corrugated walls, glossy white paint, and provisions for windows, power, potable water, sewage lines, telecommunications, and air conditioning. Permanent modular construction, PMC. Buildings are manufactured in a controlled setting and can be constructed of wood, steel, or concrete. Modular components are typically constructed indoors on assembly lines. Modules construction may take as little as 10 days, but more often 1 to 3 months. PMC modules can be integrated into site-built projects or stand alone and can be delivered with MEP, fixtures, and interior finishes. Buildings are 60% to 90% completed off-site in a factory-controlled environment and transported and assembled at the final building site. This can comprise the entire building or be components or sub-assemblies of larger structures. In many cases, modular contractors work with traditional general contractors to exploit the resources and advantages of each type of construction. Completed modules are transported to the building site and assembled by a crane. Placement of the modules may take from several hours to several days. Permanent modular buildings are built to meet or exceed the same building codes and standards as site-built structures, and the same architect-specified materials used in conventionally constructed buildings are used in modular construction projects. PMC can have as many stories as building codes allow. Unlike relocatable buildings, PMC structures are intended to remain in one location for the duration of their useful life. The entire process of modular construction places significance on the design stage. This is where practices such as design for manufacture and assembly are used to ensure that assembly tolerances are controlled throughout manufacture and assembly on site. It is vital that there is enough allowance in the design to allow the assembly to take up any slack or misalignment of components. The use of advanced CAD systems, 3D printing, and manufacturing control systems are important for modular construction to be successful. This is quite unlike on-site construction, where the tradesman can often make the part to suit any particular installation. process of manufacturing precast concrete begins with the use of molds and the placement of rebar inside the molds as needed for reinforcement. Concrete used in the production of precast concrete products has a minimum compressive strength of 5,000 psi. Production is done with a team of skilled professionals using the best equipment in the industry. Concrete is made by mixing aggregates, cement, water, and other additives to promote strength and durability. Each piece of precast concrete will be produced in a controlled environment. It's important to note that not all precast concrete is prestressed with cable reinforcement. The addition of this reinforcement is particularly useful in many structures and buildings where maximizing the strength of the concrete is essential. The addition of the wire or rebar provides tension within the concrete, which is released once curing is complete. The release of the wire or rebar tension transfers strength to the concrete, creating an even stronger material. Regardless of whether or not prestressing is a part of the equation, this process is faster, safer, and more affordable than standard concrete. Precast concrete materials help you maximize your project's potential while making sure it is completed on time. They are also among the most versatile products in construction, combining a strong structure with the ability to choose any combination of color, form, or texture, integrate facades, meet compatibility requirements for historic structures, create everything from small sections to long open spans, be recycled or reused upon removal or replacement. High-quality concrete is mixed to precise specifications, often using admixtures for faster curing or improved strength. Steel reinforcement bars or mesh are placed within the molds for added strength and stability. After having a concrete poured into the forms, the concrete cures through a process called hydration to its required strength. Again, precast concrete has significant advantages over poured-in-place projects. After the production is complete, the pieces of precast concrete are now ready to be transported and assembled at the job site. Why choose precast concrete? Precast concrete is a suitable choice for many types of concrete construction projects. This would include residential or commercial retaining walls, buildings, septic systems, drainage, and more. Because precast concrete is manufactured in ideal production conditions, you can be sure you are getting a quality, ready-to-use product. Manufacturing process uses advanced equipment that ensures that your concrete will not be subject to challenges that can occur during on-site pouring. Precast concrete manufacturing begins with careful planning by the customer. Next, production begins after approval of the shop drawings as discussed with sales team. Finally, the product is ready for delivery or pickup. Every step is taken in a controlled and organized manufacturing facility. So when the precast concrete arrives at your job site, installation can begin right away. Assembly of precast concrete houses. Building faster and smarter. Building houses with precast concrete elements is gaining traction worldwide due to its numerous advantages. I understand you're interested in the assembly process, so let's dive into how these houses come to life. Preparation. Foundation work. Before precast elements arrive, the foundation is prepared according to the house plan, ensuring a level and stable base. Delivery. Precast walls, floors, and other components are manufactured off-site in a controlled environment. These individual parts are then securely transported to the building site. Equipment, cranes, forklifts, and other heavy machinery are necessary for precise placement and lifting of the precast elements. Assembly, layout, and alignment. Guided by laser levels and markings, the precast elements are positioned into their designated locations. Precise alignment is crucial for structural integrity. Connections. Steel plates, bolts, and grout are used to connect the precast elements together. These connections create a strong and seamless bond between the parts. Internal fittings. Once the main structure is assembled, windows, doors, and other prefabricated components are installed. Internal walls, plumbing, and electrical work follow. Finishing touches. Roofing, siding, and final cosmetic touches complete the construction process. Depending on the precast system, some finishing work may involve applying additional insulation or cladding materials. Benefits of precast assembly. Speed. Construction time is significantly reduced compared to traditional on-site brick and mortar methods. A simple precast house can be assembled within a few days, while larger projects may take several weeks. Quality. Controlled manufacturing in a factory environment ensures consistent quality and precision in the precast elements, minimizing errors and rework. Durability. Concrete offers inherent strength and weather resistance, leading to durable and long-lasting structures. Cost-effectiveness. Reduced construction time and improved quality can translate to lower overall project costs, making precast a viable option for cost-conscious builders. Environmental advantages. Off-site prefabrication helps minimize waste and dust generation compared to traditional construction methods. Key considerations. Design limitations. While precast offers flexibility, complex architectural designs may be challenging or costly to achieve compared to traditional methods. Transportation logistics. Moving and handling large precast elements requires careful planning and infrastructure considerations. Skilled labor. Assembling precast houses requires experienced professionals trained in handling and connecting these heavy components.